Good morning, everyone, and welcome to today's Masterclass, one of the marquee events of the University of Melbourne's 11th Annual Science Festival as part of National Science Week. My name is Julia and I will be your host for today's Masterclass and all of the Masterclasses happening this week. As the host, I'd like to acknowledge the traditional owners of the unceded lands on which we are filming, the Yorta Yorta, but also to the near south, the Taunurong of the Kulin peoples. Aboriginal and Torres Strait Islander people are this country's first scientists, with deep and enduring knowledge of the land, waters and skies. I pay my respects to elders past and present, and I welcome all First Nations people here today. In making this acknowledgement, we commit to respectful and responsible conduct towards all others according to the traditional laws of this land, particularly at times of formal ceremony. Today's event is The Secret Life of Sheep, How Technology and Animal Behaviour Research are Shaping Agriculture, with Danica Parnell. Now, if you've tuned in to other masterclasses this week, you would know we are coming to you live from different campuses for every masterclass. And today we are at Dookie campus, which is an agricultural facility set on the hills between Shepparton and Benalla in Victoria. The campus is situated on 2,440 hectares and includes a small community that houses our students and teaching staff, merino sheep, an orchard, a robotic dairy, a winery and a natural bush reserve. And right now we are in the rotunda, which was originally built to be a dairy on the farm and now is used for livestock handling classes. Very cool space. So how today will work, and similar to other masterclasses if you've tuned in. So Danica will be giving about a 30-minute presentation about her work, and then we'll be taking questions from the audience. So please have your questions ready to go. We'll aim to finish up at 11:30. So to ask those questions, there is the Q&A function, that's all open, so pop them in there. There'll also be some polls, and so watch out for those. They will just sort of appear automatically on the screen for you to answer, all multiple choice. And the chat is also open, so for any comments you have, maybe some clapping, cheering emojis, all of that is welcome, but of course, please be respectful. So to make sure everything is working at the moment, open up the chat and pop in a comment. Let us know where you are coming in from. So maybe it's your school, maybe it's the suburb you're in, maybe it's the state, maybe it's the country, who knows. We have had lots of people from all different places in the world that have tuned into the masterclasses previously, and it's been great to see. So let us know. Oh, already people coming in, that's right. Bendigo, amazing. Welcome, April. Elstonwick, fantastic. Binjaroo, Yalluk Community School, amazing. Warrnambool, hello everyone. Gippsland, lots of people from regional Victoria, that's amazing. Keep coming in, everyone. Let us know where you're from. Dookie as well, hello. It's someone from the office, amazing. Okay, fantastic. Well, thank you so much. Keep adding those comments to the chat. And now, without further ado, I want to welcome Danica. Come on in. Come from your intro spot. Hello, how are you going?
Good.
Very good.
Thank you for having me.
Absolutely.
And happy National Science Week.
Absolutely. Okay, well, that's all in. Everyone's all ready to go. So I'll hand over to you and I'll be back to help out with the polls and then for questions at the end.
Yeah,
Thank you.
perfect.
All right.
All right. So, I mean, I guess one of the most important things to sort of start off with is, why is animal agriculture important? And, 55% of the Australian landscape is actually used for agriculture, and nearly 90% of that is used for livestock production systems, whether that's grazing on native pastures or introduced pasture species, which is really cool. And it is also quite pivotal because in the next 25 years, we actually need to feed an additional 2 billion people. And that's, it might not seem like a lot, but really that is a huge amount of people that we need in a really short amount of time. And that's where research, like things that I am doing here on Dookie campus, does come in. So we actually have quite a lot of research activities here. One of them is a trial that I'm working on, which is the long-term drought resilience trials funded by the Future Drought Fund. And when we also have quite a lot of agronomy stuff going on here, which is also funded and supported by the GRDC. Now, when we actually look at animal behaviour research, traditionally we do use behaviour as an indicator for welfare. So we look at, how the animal is sort of thriving in their environment. And we sort of try and measure that by looking at changes in their behaviours or their patterns. So whether that's reduced feeding, resting, socialisation, and we can see if any changes in those signal stress, discomfort, and it can often actually indicate health issues before we can physically see symptoms sort of appear. In animal behaviour research like what I'm doing, we want to use it to actually get insights on how the animals are investigating their environment. So how they understand their environment, how they move around their environment, and potentially use that to create management-based decisions on how we can best get the animal to graze an entire area. Now, traditionally, we do actually use objects like binoculars, and we use that in conjunction with ethogram tables. So how we study those is we actually will spend time in a paddock looking at sheep. And sometimes they can be really long hours where you might observe an animal between 7 a.m. and 7 p.m. And you want to record different behaviours at different times. So you might want to record how many times they are eating, or how many times they are foraging, how many times they are sleeping, standing, and whatnot. Now, they are really great forms, or it's a really great form to sort of study behaviour by just looking at your animals, but there is a downside. It can be quite intensive. It can be long hours, and sometimes you might not want to study a sheep at 3 in the morning because they're not doing much but sleeping. And that's where we can actually use things like technology. Technology can also help us sort of understand what animals are doing at certain times. Now, a simple and quick form is actually by using satellite imagery. When we use this, we can sort of get a quick image or a quick idea of what animals we're doing at one point in time. So for example, on the slide here, you can sort of see that this is a paddock that we have on campus, and we can see that there are, sheep all over the place, but there are also different points where animals have been or repeatedly been. So for example, we can see there's large walking tracks on the left-hand side where they've come and entered into the gate and they've left. We can also see points near the dam or towards the dam where they've sort of resided or gone back and forth to. And then we can also see an additional feed point where hay has been dropped, just to give them an extra top up from what is already available in the paddock. But there are actually other things that we can't see. And now I want to put you guys in the mindset of a sheep. Put your head into the hooves of a sheep, and I'll throw a question to you. Where do you guys think that sheep would spend most of their time at night?
Okay, so this is a poll that's about to come up.
Yep.
I saw your eyes look at me. So, all right, everyone. So there's a poll coming up. So where do you think animals should spend time at night? Under the trees, in the top right? Oh, right, on the thing, right.
Yep.
Sorry, I wasn't, okay, focus. By the dam, around the dam, by the trees, in the middle, left of the paddock, any way they feel like.
Yeah, well, what do you think,
Yeah,
Julia?
I don't know. Well, I'd like to think that anywhere is fine.
Yeah, definitely.
Maybe, but if it was other three, where would I like to be? Maybe not near the dam, because I'm worried I'd wake up and then just fall into the dam.
That's fair, I'd feel that
I'm
too.
putting myself into the hooves of the sheep. Maybe under the trees, that sounds lovely.
Yeah,
that sounds
absolutely.
like a nice little spot to sit.
Do you think you'd sort of be up in the top, or do you think you'd be at the bottom of the paddock in the trees?
Yeah, top, I think.
Yeah. Top's a good place to be.
Okay, so, so that's gone. And we have the results. Okay, thanks everyone. So we've got 38% agreed under the trees. Great, everyone, that's good. 27% by the trees in the middle left of the paddock.
Okay.
And then anyway, they feel like was 31%, but no one wants to be around the dam. I get it. You don't want to fall into the dam.
Yeah,
It's fine.
yeah, no,
All right.
that's completely fair.
Okay, well, I'll hand over to you to let us know what the real answer is.
Yeah, so you're pretty much right. By the tree lines, if that's what you sort of guessed, upon closer inspection, you can actually see that there is kind of a campground sort of established. And that's obviously because of a shading reason. But there are a couple of other things that you might not be able to tell just by this one image. So when you actually go and have a look at this paddock, that is actually the highest point in the paddock. So it's also at a higher elevation, which sheep normally do like to do. When they are camping, as they are natural prey species, they will spend time in areas of highest elevation so that they can sort of scout the entire sort of landscape. But, you might also think, okay, but there are tree lines, off to the left. Why don't they go there as well? And we can kind of see when we take a closer look that there are tracks that do go towards that area, but they don't actually enter or camp in that area. And you might be wondering, why that is. But you actually need to take a bit more of a closer look than what satellite imagery can give us. That, for example, if you are having a quick look at the photo, it does sort of tell you that, there could be differences in the quality of the pasture based on the fact that, there are some areas that are darker and some areas that are lighter. But actually, it could actually come down straight to pasture variation. So this is a different example from a different grazing trial, one of the ones that I'm currently working on, where we have sheep grazing on wheat. And over 7 days, they just kept grazing the exact same area. Even though that there was plenty of biomass available elsewhere, they just repeatedly grazed that one spot. And that is actually, a pretty natural sort of thing. Sheep will graze or continuously graze down one area based on nutrition. Actively growing plants are more nutritious or more tasty for sheep to be eating compared to older pasture that is sort of hitting maturity. Even though it is lush and green, there would sort of be a bit more sugar as plants are actively growing as well. So that could be a different thing. Now, let's compare different time periods. So we'll have a look between these two photos, which were taken again by satellite imagery on campus. One was in June 2023 when we had quite a lot of rainfall that year, and the other one was taken in May at the start of this year, well, earlier on this year, where we didn't have a lot of rainfall. But what we can see is there's still a water source, whether that's supplied through a dam or a trough as well. There's still a feed source aside from what's available in the paddock. But in June 2023, sheep are all over the place, and we can kind of see that through the little white specks that are everywhere. But in May this year, they kind of camped out onto one side. So why is that? Why could that be? I think we do have a poll here,
Oh, we
Julia.
have a poll. Okay, great. Okay, let's have a look, because I was really questioning what that would be. Okay, it's coming up, everyone, so it should appear soon. Why do you think sheep congregate in different areas in a paddock in these two time periods? Okay, so first, feed availability. Did you mention that already, possibly? Sheep like having friends close by. That does make sense.
Yeah.
Yeah, friends are nice, yeah. Weather, good point, but is the weather different at different parts of the paddock? Oh, but different times.
Different time periods, yep.
Yep. Time of day or all of the above? All of the above's always there.
Yeah, what are you thinking?
Well, I mean, you did mention the feed availability,
Yep.
and maybe something's different at the different time.
Yep.
I feel like the sheep will always be together with their friends, maybe.
That's true.
Yeah,
That's
yeah.
true. We know that sheep sort of mob together in groups of 4 or more.
Okay.
When there's 4 of less, sometimes they, get a little bit scared and they won't venture off.
Okay, all right,
Yeah.
yep. So if one person thinks that one area is better, they might actually go there.
Exactly.
Interesting. Okay, answers are in. So we think, 53%, all of the above. Yeah, I mean, there's lots of different options there, and that encompasses everything. But the next top is the feed availability, 23%. Like myself, very good, everyone. Or we don't know yet, we'll find out. And 13% thought weather and 10% time of day.
Interesting.
What could it be?
Well, it actually could be a variety of things.
Oh, there you go. Okay,
could be a
well, I'll leave you
variety
to
of
it.
things. So, thank you, Julia. So if you had said time of day, in the instance of satellite imagery, you're actually correct. Pretty much because the one thing that it can't tell us is at what time period did it actually take these images. So in June 2023, we can assume that it was sort of either early in the morning or later in the afternoon, just based on the shadows there. Whereas in May, we could assume that it was taken sort of in the middle of the day where we don't really see much shadowing on the trees as the sunlight's coming directly above. And during the middle of the day, sheep will often spend more time camping or sort of resting and ruminating as opposed to actively grazing. And that could be why we're finding a large presence with the mob on the right-hand side versus sort of all over the place eating food. I know I sort of tricked you there a little bit by saying feed availability is one of the options, but we do see that, despite differences in potential pasture quality, there is an additional source of feed and tasty grain that was also available. So that indicates to me that it's potentially a time of day thing. But for all those people that did say all of the above, you are technically also correct. Lots of things can actually influence where sheep spend time in a paddock, and that isn't just down to feed availability. Research has sort of highlighted that, yes, feed availability and feed quality is one significant factor, but it also actually does come down to individual animal behaviour. It also, as I mentioned earlier, does impact or time of day does impact where sheep will spend their time. But smaller things that people don't often think about as well is weather. Rain, sunshine, even wind can impact how much animals will choose to graze and for how long they might graze for. They might graze for shorter periods of time throughout the day instead of doing a nice long graze. And similarly, fence lines and presence of water troughs or, man-made shelters or trees will also impact what gets used and at what time these things get used. But also, part of studies that I've done, part of my PhD, did find that landscape variables mattered. So that's like slope and elevation as well as aspect. So if a slope is facing east and west or west to east, which is pretty fascinating if you ask me. But this all actually impacts overall paddock utilisation and so too pasture productivity. So sometimes it's not just about the animal, it is also about what they are eating. Now, in particular, we've actually been able to identify these types of things based on using tracking technology. So they are more available than ever. And I do have two small examples here. One with a handheld sort of GPS, where, this is something that people would use to track themselves, whether they might be going on a bushwalk or a hike somewhere, or we actually use this to track some of our sampling locations. One of the things that you guys might commonly see is actually just a little smart tag or an air tag. These will track location as well. But the purpose of these is to actually reduce labour costs. So you don't have to stand there and, watch, where is my animal or where am I going, and, be as cautious and careful about it. These devices will track animals automatically or people automatically 24/7. The best part about it is they are also actually getting smaller, cheaper, and more advanced over time, which allows us to have a way of monitoring the animals that is non-invasive as well for them. Now, GPS trackers, a little quick overview is that they pretty much use a constellation of satellites to locate a particular receiving unit on Earth. So in the instance of the GPS device, you might find that it will require about 3 satellites in order to get a signal or a response. This type of technology or GPS tracking is not new to research. We do use this quite often in conservation and wildlife science as well. But it is something that we're sort of starting to get into for animal agriculture. Now, the important thing to know with GPS devices is that these GPS trackers will get attached to an animal, and how it gets attached to the animal really depends on the species and the environment in which that they are going to be studied in. For example, recent studies by the University of Melbourne actually placed GPS and accelerometer trackers in mini backpacks for bearded dragons, which was a pretty cool study. And it actually found that slow and steady wins the race. The slower bearded dragons actually, thrived and lived much longer than the ones that were pretty quick. In the instance of livestock, we've found that through research, if a device weighs less than 1% of their body weight, it actually has no impact on their behaviours at all. And it's something as small as about 300 grams, which for them is kind of like nothing. Now, GPS data, what we do get out of it is we can sort of show and see patterns of animal movement and how they use their landscape or their environment altogether. And it also actually can show us things like habitat use amongst animals, amongst other members of their herd or mobs, and how they relate to each other. So a really awesome example here is by the tracking wolfpack territory in Minnesota. Researchers actually placed GPS collars on a couple of wolves in different packs, and they found that they never actually crossed each other's territories, which was a really fascinating thing to see. We can also actually use them on birds, which are tiny little collars that get attached to their feet, and we can track their migratory patterns. So where they go, do they return to certain areas as well? And seals get tracked on their flippers, and they get tracked pretty much from where they go when they're resting in California on the nice beaches there, and then when they go out to sea, where they go and what they do before they come back. Now in livestock, again, this is where, my area of expertise sort of comes in. We've placed GPS collars on around a neck of a sheep, just to give us a general indication of where they are at all times. And the collars that we use there are actually designed to be tracking them 24/7 in all different types of weather. So they are quite weatherproof. And this is just a quick example from one study that I did, where we looked to see sort of what drove animals to graze in different areas, whether, that was landscape variables, environmental variables, or just each other. We can kind of see that just from this quick average for all of the different seasons that we did study them in, there were areas that were used and areas that weren't used. But how do we actually know what they do at certain times? Well, that's where accelerometers come in. Now, accelerometers are small battery-powered sensors, and they can record data at a really high frequency, so less than a second, but they can also record data at different time points as well. And we want to sort of track and see what type of behaviours are exhibited with these accelerometers. So they give us unique movement signatures from 3 directions. So your static X, which is your left to right, your static Y, which is your up and downs, and your static Z, which is your forwards and backwards. Now, the rate of acceleration or the patterns that you do see really depends on the placement on the animal. So something that you might see is where you have an accelerometer placed on the cheek of a sheep, and that's just to look at bite pattern and bite behaviour. If you place it on the back of their neck or even on the front of their neck, that can capture things like every time they place their head down to start grazing or stop grazing. And if you just place it on the back of the animal, that's just to generally sort of track, are they lying, are they standing, or if they are walking. Now, the data that we do get out of it can look kind of funky, and that's okay. But the point is it'll give you different patterns of behaviours based on acceleration. So the data that we get is pretty much a signature or a movement signature. And this can sort of help us understand what the animals are doing at a time where there are no visual observations. And the other things that we can use with this data is pretty awesome, because we can actually calculate an overall dynamic body acceleration, which is the sum of all 3 axes, and it basically will tell us what the total energy expenditure is required to perform a particular task. Now, you guys can actually try this out at home as well. There is an app that you can download called Physics Sensor Toolbox Suite. I'm not sponsored, but they're probably one of the best apps that you can use if you want to try this sort of stuff at home. You can also track yourselves with GPS using that app as well. But the accelerometer ones is pretty awesome, because your phone actually has an inbuilt accelerometer in it to determine things like screen orientation. It'll track all of your steps, and even help with motion-based controls for things like augmented reality, if you were into that when you use Pokemon Go. Now, this is an example that I did where my phone was in my back pocket and I had the accelerometer tracking what I was doing. And you can kind of see that there was a really large up and down movement. And that was every single time my leg was raised as I was walking. Same as we have a consistent pattern for our forwards and backwards, or our static Z, where as I was moving forward, it was obviously recording that data that was what was happening. We do see some slight movements in our left and right, or our static X, and that was pretty much if you've got a little bit of a sway in your step. Now, I do want to throw it out to you guys. I want you to try and put your mind into someone who wanted an accelerometer or wanted to track themselves with an accelerometer. Can you try and take a guess at what any of these behaviours are?
Okay, so we've got another poll coming up. Let's see. All right, so can you guess what these movements are? Okay, so
for the first one,
yes,
we will have spinning in a circle, jumping, or potentially sit-ups and crunches.
Okay, so there's 3 options, and so we're looking at the first one on the left-hand side of the screen. Okay,
Yep.
great. So what does that mean? Spinning, jumping, sit-ups, crunches.
Yeah. What do you think?
Well, yeah, it's not much movement.
No.
So either sit-ups or spinning, I would say.
Yep, that's a pretty good guess.
I'm going to go with spinning.
Okay, yeah, that's perfect. When you think about it, you want to look at what is happening with your forwards and backwards sort of motion. So if you think that it could have been your left and right, that was what was causing a lot of movements, it really depends on how you're spinning in a circle, I guess.
Yeah, that's true. 61% of everyone out there believes it's spinning. Well, guessed it was spinning in a circle.
Yep.
And next was sit-ups and then next was jumping.
Yeah, wonderful. So if you did guess spinning in a circle, you are correct.
Woo!
So we can kind of see that there is a bit of a movement with the forwards and backwards, and that could be just because you are spinning like this. I was actually sitting in a chair and spinning around in my office, so we could definitely see there was not a lot of movement in the up and down, and that's why that's the case. If you were to try it standing up, you might see a little bit more variation in your up and down movements.
We're going to keep going with the other 2?
Yep.
Okay, all right. So I don't know whether the poll will be able to appear. Oh, can. Okay, great. All right. Oh, no, wait, that's the PowerPoint. So the next one, so it's either jumping
or sit-ups and crunches. I mean, you could guess spinning in a circle as well, but you never know.
That one's done. Yeah.
It is a little bit past.
Okay, so we're looking at the middle one?
Yep.
Okay, so jumping or sit-ups and crunches.
Any thoughts?
Well, based on the third one that looks very extreme, and I'm guessing that might be jumping, I'm feeling like that might be sit-ups and crunches. But who knows? Let's see what everyone else thinks.
Yeah. So...
Sit-ups and crunches, 56%.
Haha, okay, interesting. So this is actually jumping. So you can actually see the biggest tell between the two of them compared to the last one, which is sit-ups and crunches, is there are isolated events. So jumping, we can actually see that there is definitely a big up and down movement, which is when you're squatting down and then actually jumping up into the air. Versus when you are doing sit-up and crunches, you know, if you're like me and you're a little bit lazy, you might lie down on the floor for a hot minute before you go up again. But when you do that movement, you actually expect a larger forward and back motion than an up and down movement. And that's what the biggest difference is between the two of them.
There you go. Fascinating. Very good. Right, I'll leave it to it.
But great guessing, everyone. And thank you, Julia. If you actually didn't get that, that's totally okay, but that's actually the point. You know, sometimes you can't easily understand what accelerometer data is unless you knew what you were doing. I mean, although there were some pretty good guesses for the first one, I might add. But, you know, and a key example of this for not knowing or not understanding different types of data is actually through captive dolphins. So researchers had an accelerometer placed on a wild individual, and they had it over a period of time, and they saw different signatures, but they actually weren't sure what those signatures were. What they could do actually, however, was put a accelerometer on a captive individual, so an animal that they were studying as part of, you know, its rehabilitation process. They put an accelerometer on its fin, or on the top of its head, and they actually found, by observing at the same time as using the accelerometers, that they could see specific behaviours. So one of them was a distinct twirling behaviour, a distinct breath behaviour, and a distinct swim burst behaviour. And they were able to identify these by obviously having someone standing there at the same time as that data was recording. But then they were actually able to then take that data and compare it to a wild individual, where you could see that if you're going from left to right, there's a slight breath behaviour, then they get into a twirling behaviour, or a swim burst behaviour, sorry, a breath behaviour again, a twirling behaviour, and then another breath behaviour again. So it's pretty fascinating, but it sort of highlights, you know, even though we do have these technologies available, sometimes we still need to actually go out and have a look ourselves. So I guess if I'm taking it back to sheep, we can sort of get an idea of what we've learnt by using these technologies. In one study that we did, in half-acre blocks, we saw that more sheep were present, obviously, when there was more biomass available. So as biomass increased, so did residency by the sheep. But what was interesting was when there was a presence of legume, or sheep chocolate, if you'd like to call it, there was actually a strong effect of a legume presence. So when a legume was around, or a little block of chocolate was around, you would find more sheep in that area than anywhere else. Even if there was only one little square left available, they would still spend time in that area because they thought, hey, there could be more chocolate around, let's hang out here for a little bit. In this study, we actually also found that mobbing behaviour by sheep often outweighed the want or the need to sort of graze. So they spent less time grazing and more time just hanging out with each other, spending time near fences where they could see other sheep as well. And that was particularly apparent when there were less than 4 sheep. Then when we had 6 sheep in a different plot, they actually, you know, ate to their heart's content. And that does have a knock-on effect in terms of live weight gain, or looking at, you know, their progressions in weights, because if you have animals that are spending more time grazing and eating food, they will put on more weight in comparison to those that, you know, kind of just want to hang out. Now, in a different region with different pasture types, different area, different seasons, there was actually no influence of behaviour. There was no sort of mobbing effect or no sheep that sort of didn't spend time grazing. They all kind of just grouped up together in a big mob of 25 in their respective paddocks, and they all sort of grazed areas pretty consistently. But we definitely still saw an impact or an influence on feed availability and quality, and that was statistically significant. And we use that measure by checking NDVI, which is just a value of greenness or a proxy for quality of pasture. But we could see that it actually drove the animals in an improved pasture to graze more area in comparison to a native pasture. And the biggest difference is actually what we can see in terms of utilisation rates. So in these 22 hectare blocks, in a native pasture, so it's usually grasses that are from Australia that don't really tolerate grazing pressure too well and aren't as nutritious or as tasty, I guess. We actually only saw about 30 to 40% utilisation rate in a paddock and about 60% completely underutilised in 6 days. And when we compared that to our improved paddock, we could see the complete opposite, where there was about 70% of the area was used and only 30% was unused, again, in 6 days. And that, sort of highlights alone that, well, why we actually need to look at what the animals are doing and why they're choosing to graze certain areas. And are there anything that sort of influences them to move in different areas or do what they do? Now, I do need to add here that a lot of this research is still needing to be done and it's still needing to be developed. It's not something that is there just yet in terms of commercial applications. But if I were to put a goal on it, it would be to sort of collect more data and develop potentially predictive models to look at animal behaviour or understand animal behaviour. That way, we can create management-based decisions or management-based strategies to increase utilisation by animals in a paddock. And then that way, we can actually make more informed decisions about how we manage our sheep and how we manage our pastures together. And that's pretty much it from me.
And then we're done. Amazing, thank you. I mean, I was going to be asking you that question as well about what's next, but we can definitely circle back to that as well. Thank you so much. That was so fascinating. I was engrossed at half the time and forgot to come in and help with the polls sometimes. Amazing. Well, thank you. So it's only just past 11, which is great. So lots of time for questions. So reminder to everyone, there's a little button at the bottom with Q&A. So put all your questions in there. We'll try and get to as many as possible. And there's already quite a few that are coming in. So yeah, please do. While we wait for all the questions to come in, I've started with most of the masterclasses. I sort of just want to start off with a bit of your background. So what led you to coming to Dookie, doing your research here, and particularly in sheep? What's your story?
That's actually a really interesting question. I'm only 29, so I feel like my research career has only sort of just begun. But if I were to take it all the way back, it was actually my dad who sort of inspired me to go into agriculture. I kind of just wanted to, work in a research conservation centre, but just, helping out and volunteering. And my dad actually went, well, you could make a career out of that and actually get into research. And he was the one who sort of said, you were always really interested in science, so why not pursue it? So that led me into doing a Bachelor of Science in Agriculture. We're at Sydney University. And then through that, I actually did my PhD there as well, where I was really fortunate to have some awesome supervisors, shout out to Lockie and Andrew, who let me take my PhD where I wanted to take it. And that was actually just going, well, why do sheep stand in one area? Why?
Good question.
Yeah, why do they like to do the things that they do? And so that was one of the things that we were able to study. And then that eventually led me here to Dookie, where we are working on these long-term trials. And it's something that we are about to sort of implement on our trials as well. So looking at how sheep might actually graze different crops as well as different pastures.
Yeah. Amazing. I mean, that's so lucky to have that experience and that encouragement from your dad as well, and just to be able to follow your curiosity. I guess that's the great thing about science.
Absolutely.
Amazing. Well, thank you for sharing that, and I'm sure there's other similar stories of everyone out there as well. So we can get into some questions from Nuo. So onto the GPS tracking stuff straight away. So is GPS tracking on farm animals used widely in Australia?
That's actually a really good question. That is a really good question. So if we are taking it from a commercial standpoint, not really, no. Most producers that do choose to use GPS tracking only do it for a location-based thing. So they just want to know where their mobs are at a certain time. And that's actually predominantly done in far north Queensland, where there are large areas that animals do graze in. So it's predominantly used in cattle. So if you were to do a quick Google and look up, animal GPS collars, you'll actually find that most of it is made for cows. And that's using little ear tag trackers. So for producers, it's pretty much just to find out where they are, but not necessarily look at why they are there.
Interesting. Well, it's good to use a similar technology, but in different ways. Amazing. So staying on the GPS, I guess, the tracking and more the devices, and I know you did show that the bearded dragons with the backpacks on, which was super cute. But how, and I guess they found out that didn't disturb those animals, but how do you ensure the technology doesn't disturb the natural behaviour of the sheep in particular?
Yeah, so actually that is done by more research.
Yeah.
So there was a study done for livestock and sheep in particular by Jamie Manning, who is up at CQU at the moment. And she did a study that put GPS collars on and actually monitored them for about 3 days after they were put on. And she found that actually there was no change in their behaviour. They kind of just acted like normal. So on the first day she put it on, there was a little bit of shaking, like, oh, okay, there's this thing here. But, you know, to sort of put it in layman's terms, it was kind of like putting on a necklace for the sheep. It wasn't really anything that impacted them. But the main things to consider are they do need to be quite small for it to not have an impact. So if you are out there and you're trying to put a big backpack on a sheep to figure out where they are, that might cause a little bit of problems.
Yeah.
But when you do use smaller tech, it's not really a huge deal.
Yeah. Interesting. It does, I guess, relate to the next one from Helene. So how do you see livestock tracking technology being used or adapted on farms, I guess in a similar way, but, you know, different types of farms, and how could they potentially use the technology?
Yeah, so again, you know, this is where hopefully more research sort of comes in. Eventually, I hope to see, once more data is collected, we could potentially use things like machine learning models or AI to help us go, okay, well, if a sheep is spending time here in this particular paddock, but it doesn't really want to go over there, and that's, you know, what you're seeing through your larger mob of animals as well, you could actually go out and look and see, okay, well, what is it over there that they aren't doing or is doing? So in those particular areas, you could, for example, look at your pasture quality and you could go, okay, you know, that's actually not actively growing and it's probably dead pasture. So there's no feed there. And then you can actually put in a management decision and go, I need to spread more urea to make my plants grow here, to make the animals go there more. But also similarly, you could look at things like, you know, where you place your water troughs or your shade in your paddocks to try and get them to, you know, walk across the paddock more often. So we found that if, for example, you had a water trough right next to a shade location, sheep don't have to walk very far to go and get a drink when they need to. But if you actually placed it on the other side of the paddock, you might find because they do have to go there, they are more willing to explore an area to graze.
Yep, amazing. I've got one from Reva. So I guess a bit more of the application of what you're doing as well, potentially, maybe some of the research, but how can small scale farmers afford and use these new technologies for sheep monitoring? So I guess it's how do other people use it who aren't necessarily working at a university and researching?
Yeah, and that is definitely a really good question and a really great point. There are companies that are out there like Smart Track or Smart Paddock. They do provide GPS collars or sort of tracking technology.
Still not a promo, but
still not a promo. I'm not sponsored. But what they do is, for example, there will be a cost associated for the GPS collar or ear tag or however the systems are set up. And with that sort of cost, you are paying for the maintenance of the device. I cannot quote how much they actually are at the moment, but different companies will allow for different options. It really just depends on what you want to use that data for. If, for example, you're like the producers in the Northern Territory that just sort of want to know where their animals are, very simple. You can usually also actually get an app on your phone that'll tell you where they are. But if you then sort of want to get to understanding, well, yeah, why are they going and doing the things that they're doing? We're not there yet.
Yeah.
We're not there yet.
We're getting there.
But hopefully soon.
Yeah, amazing. Okay, fantastic. Okay, one from Emily. This is a good question. Do you do similar studies on other livestock? Obviously today was all about sheep.
Yep. So unfortunately, no, I don't actually do a lot of studies in other livestock, but I would love to study cows because, you know, you can also actually see individual behaviours in cows alone. So my uncle in New Zealand, he actually worked on a dairy farm and I spent a lot of time with him. And we used to throw exercise balls at the cows because they would love to just, you know, hit it back. So I find that, you know, if I could study something else, it would definitely be a dairy cow.
Fair enough. Very good.
Thank you, Emily.
Great question. And there's so much time in your career, so you could be doing lots of different things, no doubt. Okay, so one from Ifa, a bit more of I guess a bit more of the disadvantages. So radio waves from the GPS trackers are obviously being used. do you know if there's any ill effects on the sheep, on their fertility, and are there any potential disadvantages of using this type of technology?
Now, that's a really great question. That is actually a really good question. And if I'm being completely honest, I would have no idea in terms of if that actually does impact things like fertility. But the radio waves or the frequency that does come from these devices are so small, it would probably be the same as, if we were to walk around with a handheld GPS device like this, because all it effectively is doing is going, where's the satellite? Tell me where I am. So, our phones would sort of give us a little bit more than that, but we assume that it's actually not as much. But those studies sort of haven't been done. So if you are into science, you could pursue that as a research idea.
Absolutely. I love all these questions because I think it does mean that other people can be curious and find out the answers as well.
Absolutely.
Okay, another one from Helene as well. Multiple questions. This is great.
Thanks, Helene.
Yes, absolutely. So generally, what are, so back to, I guess, the sheep behaviour specifically. So what are typical types of sheep behaviour and what could be considered as abnormal?
Oh, that's a really interesting one.
Yes.
So a typical sort of behaviour that you would expect from sheep could be anything along the lines of just simply grazing, walking around in a paddock. They might be lying down and, you'll see mouth movements, which means that they are chewing or they are ruminating. And you might also hear them sort of barring at each other, and that's okay. Vocalization is also very typical of these sheep. But when you are looking for things that are atypical, you're looking at things like pacing, whether they're sort of walking back and forth or, they're sort of also panting quite a lot. Panting you might see when they are exhibiting signs of heat stress. Okay. So when it is quite hot and quite humid and if they don't have any water available, you'll see them starting to pant. And it's not just a mouth thing, it's also a full body thing. So sheep do move back and forth quite a bit as they are panting. And that can be a sign of distress for heat stress. And then, staggering and sort of stumbling around would be the other ones. Isolation is another big one. So if you see a sheep by themselves, it's often really a sign that there could be something wrong, potentially internally. They could be sick, they could be unwell, and that's when you would need to intervene.
Yep, fair enough. What's the most, this is my question, what's the most surprising thing you've seen of your sheep behaviour research?
Oh, that's a really good question.
Thanks.
I would say the thing that I thought was most interesting was seeing a sheep kind of skip.
Okay.
So if sheep are like people. They actually get to know people. They are happy with their own groups of people. So if you have a mob of, say, 50 sheep or 500 sheep, you'll find that the same 25 might hang out together and they won't really sort of interact. But then if you do separate them, so for example, when they are coming in to go and get shorn and their wool comes off, when they get released and they find each other again, they do a bit of like a little sort of skip when they run to each other. So that's probably the most interesting thing that I've seen.
Absolutely.
Never thought a sheep could skip, but hey, they do.
Sounds like it was a happy skip too.
Very happy skip.
Love it. Okay, so back to a bit more of the technology. So from Reva, so what's the biggest challenge in combining technology with animal behaviour studies? Which is, I guess, is a big part of really what you do.
Yeah, absolutely. And that is, it's not a really straightforward answer, I would say, because one of the biggest challenges for just all research, I guess, is funding and being able to actually do the research. That would probably be the biggest sort of inhibitor. But in terms of actually applying or putting together animal behaviour and technology, sometimes all it takes is just one little idea for you to be able to go, okay, let's see if we can make this thing work and this thing work. So for example, with like machine learning models, at the moment, AI, for example, they might not actually be able to tell us a lot in terms of like, how can we get animals to increase utilisation in an area? AI, doesn't actually know a lot in terms of what the environmental conditions are on a specific day, and it might not be able to sort of predict that in future. So that could be a challenge in the future once it comes to collecting all of that data and putting it together and creating these sort of models to understand why they do what they do.
Interesting. So can you see a potential positive of utilising AI in the future with your research, and how?
Well, that's a really good idea as well. I mean, again, AI is still learning and there's a lot of sort of caveats that you have to be wary of when you do use AI for this type of research or this type of thing. And you do have to be cautious because some of the things that they they might spit out might not be 100%, but it may only be about like a 60% guarantee that something could happen, which is why, and AI obviously relies on a lot of data and a lot of data input, and without that data, it won't be able to tell us anything. So yeah, I guess, you know, for AI to work really well, we still need more data, which means we need more research.
Yeah, okay. It's good, potentially in the future, but not yet.
Yeah.
So I guess, I mean, that question did relate a little bit to Emily's. So what other technologies do you use for livestock management? So AI potentially in the future, obviously the GPS. Are there other specific technologies that you're utilising?
Well, there are definitely technology that is out there that we do utilise for sheep. So for example, we actually have it's called an OptiWay, if you haven't heard of them. Again, not a plug, not sponsored. But we do have an OptiWay, which is a form of us being able to live track weight gain in real time. So it's another method or technology that we do use even here on campus, and some producers actually also use this technology as well, because it does save time and labour costs, because you are able to put this device out into a paddock, and sheep are freely able to use it and utilise it when they want. They'll go up to it, put their 2 front feet on it, and it'll actually record what their weight is. And which is really cool for producers, because if you have, for example, a target that you need to meet or you want to sell your animals at, that'll be able to tell you or give you a rough idea of when you could meet that target. So yeah, we are using a lot of different types of technology. Another one that we have here on campus, if you are fortunate to come out and see it, is our robotic dairy. A lot of that does actually use the natural behaviour of the cows to actually want to get milked. The main thing is it's stress-free and it's completely elective. So the cows can choose to walk up to the dairy and get milked by the robotic milking system. The other benefit of it as well is that we can actually find out, you know, if there are any issues with particular animals and individual teats a lot earlier than if you were to visually wait for signs.
Amazing.
Yeah.
The robotic dairy is fascinating. I'll do a shout out to my team in the background to hopefully put a link in the chat to put some details. But potentially, maybe next year for National Science Week, we should definitely visit that and share some more details, because it is a really fascinating,
Absolutely.
facility out there. Now you talked a little bit about the sheep and I guess their like how calm and how over the top they are. I guess their emotional state. So do these technologies and the research that you're doing, does it show what environment calms a sheep or what makes them aggressive? Like, is there some sort of something that you can highlight?
Well, not particularly, no. It's not, again, it's not as straightforward as with a lot of, you know, research can be. Sometimes you think it's going to be a really clear indicator of what it is. Sometimes it really isn't. So for example, one of the studies that I did with the improved and the native paddock, one of the assumptions that we've made as to why the native paddock sheep didn't actually use a lot of that area was because right where some of the best quality pasture was actually right next to the gate, and opposite the road from the gate was actually the shearing shed. And they know that every time they were going to get shorn, there would be a vehicle coming or a dog coming to come and help round them up and bring them into the shed. And they weren't huge fans of that. So that's what we were sort of trying to see and sort of understand. Okay, well, maybe it's a experience that they had within that particular area that influenced why they didn't use that area.
Yeah. Interesting. Okay.
But we wouldn't have known that unless we, you know, well, if we weren't there, we wouldn't have known that. But because we were there over a couple of periods, we could see, okay, you know, in April, they weren't grazing that area. In September, they still weren't grazing that area. In January, they still weren't grazing that area. And why was that? Well, it's probably because of the dogs and the cattle.
Yeah. Okay. Amazing. And I believe I've just checked, so there's a link in the chat from the dairy farm as well, so go check it out, but not yet, maybe after the show. Okay, so there's maybe about 10 more minutes or so, so keep sending in those questions as well, but I did want to touch on a few other things. One particularly a bit more about your background, I guess, and any, I guess, what type of background would be best for someone working in your sort of field now, like a science degree, and where is best to start to be able to come into this sort of field?
Well, university is a great place to start. Yep. Coming to uni obviously is one of the key ways that you could get in, but there are also other pathways. Now, like personally, I found that it's, as long as you're willing and able to be curious, that's sort of what will get you a lot further than simply just a degree or, you know, what you chose to study and why you chose to study, the things that you do. So for me, again, a Bachelor of Science in Agriculture, I also did my honours as well. And an honours is basically a little taster for research. And then if that really does sort of strike your passion, so you can definitely get jobs as like research assistants, which will also give you exposure into a research area. And you can do those in a variety of different places. So for example, you could do work with crops, you could do work with animals, you could do, I know part of my stuff that I did after my honours was working as a bushfire research assistant. So I set things on fire for 2 years, which was pretty cool. But then that was what I actually did before I did my PhD. So as long as you're open and willing to remain curious, like you could really go anywhere.
Absolutely. And there's a lot of bushfire research that we actually covered just yesterday in the science masterclasses as well. Now, I do want to go back as well. We spoke a little bit about, small farms and how they can utilise the GPS devices as well. But I guess beyond that, I guess the applications of the work that you're doing, do you have a lot of connection with the farmers and suggestions and recommendations for how they might work with their sheep? Is that sort of where your research leads to?
Yeah, so the goal ultimately of any bit of research is to make it practical and applicable for an end user. So in my instance, that it's definitely for farmers and producers. And what we want to do with data that we are collecting is take that knowledge and take that information and go, okay, well, how can we best manage our sheep, or how can we best utilise our pastures? And that could be, for example, changing how we graze them. So we could do things like strip grazing or cell grazing, where we can change our stocking rates, where we can have higher stocking rates for a shorter period of grazing, in hopes that they might actually graze an entire area, as opposed to having lower stocking rates and giving them a large area to graze.
Yeah. Absolutely. There's a lot of benefits for it.
Yeah.
No doubt a lot of farmers are looking to you for more guidance. Okay, so back to one from Emily. So a little bit more about, I guess, the emotions of the sheep, and like, is it observable, the negative emotions, say for example, when maybe another sheep dies or moves on, or is that quite obvious from your research?
So you can often tell that there are more bleating or barring sort of behaviours when sheep are sort of stressed, or going, what the heck's going on, or what's happening here? But over time, they do often then go, oh well, you know what? There's a piece of chocolate over there in my legumes over there, so I'm going to go over there and eat it. So you do see those behaviours for a short period of time before they then move on and go, okay, well, I'm a bit hungry now, better go eat.
Yep, fair enough. Okay, so you can see some of those obvious responses, I guess. Okay, one from City. So there are many grazing animals that farmers take care of. Why did you choose sheep for your research?
Really interesting question. Again, I would have loved to study cows as well as sheep, but it was actually just something that was available to us in terms of one of my supervisors actually had done work with Jamie Manning, who I mentioned earlier on, and both of them had done quite a lot of studies in sheep. Okay. So for me, it was just, something that was quite available in comparison to if we were to study cattle. That meant that we would have need to get a whole different set of devices or larger devices to be able to track them.
Fair enough. So in terms of your work with the sheep, we've seen a lot of really interesting studies. What is a typical day for you? I mean, are you always out in the field? Are you always connecting tracking devices? Or a typical week, actually? That's what I've sort of asked. I know a typical day is very hard to distinguish, but just tell us a bit about a typical day of your work.
Well, I mean, every day is different. Every day is different. You kind of have to be prepared for anything to happen. Some days you might find that sheep have knocked down a fence and you've got to go find where they are and how they knocked down a fence. Or some days you might find that they're just hanging out in the paddock and all you have to do is just check that they're okay, they've got water, they're all good to go. Some days it's sitting behind a computer, reading more literature and trying to see, has anyone else tried to make these connections? Because another big part of science is it's actually quite a collaborative community. A lot of the stuff that we do might require other people from other areas in science. Integrating and working with each other. So some days it might be reaching out to people going, hey, have you ever experienced this in your studies or your trials? And then other days it could be looking at feed quality. So we're working in a lab, we're grinding samples up. And, thankfully I have some really awesome colleagues who do help me with that as well. And then, some days it's also just helping out, doing things as you usually would do with other researchers as well, even on the farm.
Yeah. Absolutely. What's your favourite part of your job?
I would say definitely driving around in the buggy that we have.
Oh, yeah, okay. That sounds fun. What do you do with the buggies if you had to get around the field?
Yeah, pretty much. Our trial site is just on the other side of the road on Dookie campus. And we are actually having an open day on the 8th of October where we will be showing off our trial and some of the other research trials here. So if you are interested, I think some details will be posted later.
Okay, amazing. And everyone can see your buggy as well?
Yeah,
Okay,
probably.
that'd be good. That'd be another draw card. Okay, yeah, a few more final questions. So yeah, a bit more of the applications and commercial use. So is tracking technology for livestock currently used commercially?
Yeah, so as I sort of mentioned earlier, it's not really being used too often, but it's only in certain situations. So again, far north Queensland, a lot of producers will use it to sort of track where their livestock are, but that's about the extent of it. I don't know if it's actually being widely used in sheep just as yet, but I do know that there is a large market for livestock producers for cattle up north.
Yeah, fair enough. So in terms of your work here in Victoria, do you connect a lot with similar researchers from across Australia? And are they working on similar or different projects because of the different types of land that, you know, Australia is so vast and different?
Yeah, absolutely. I mean, it's not even just within Australia. There are people that you can speak to internationally or overseas.
Yeah.
There are a couple of people that have done work in the US that we talk about in terms of their pasture management and how they graze their sheep and how that actually does differ to how we graze our sheep. We actually have a really awesome research fellow here who he's visiting from China at the moment, and he was so shocked when he saw that we were grazing our wheat because up in China they don't commonly do that. So it is interesting when you see there's diverse opinions and diverse areas of expertise. You know, people do different things in different regions.
Yep. Fascinating. And so part of your work, you're doing a lot of research, obviously. Is there teaching part of what you do here on campus as well?
So technically my role is research focused only.
Okay, all right.
But I do give some guest lectures here and there on a couple of things, and one of them, which you did see earlier on this year, was actually on animal behaviour.
Yeah, very good. Do you enjoy that part of your work as well?
Absolutely love it.
Okay, amazing. Okay, well that pretty much brings us to the end. Do you have, I guess, I know someone already asked a question sort of about moving into this field, but I know like these masterclasses, there's a lot of students coming into that, potentially in primary school, high school. Is there any like particular takeaways you'd like them to consider in terms of potentially moving into science and this field?
Stay curious.
Yep.
Always have an open mind and stay wanting to learn more, because the moment you sort of close your doors and choose not to wonder why things happen, then you know you really limit yourself and you put yourself in a box. But as long as you have an open mind and you're wanting to learn different things, the world's your oyster.
Amazing. Thank you.
Thank
you so much.
No
Thank you for your wisdom, all your work. It's fascinating, and for answering the many questions that came in. So it's been great. Thank you all also out there for joining us. The Science Festival Masterclasses will be held throughout the week, and if you would like to attend another session, please register and go to the Science Festival website. So as I said, we're here at Dookie, but we're heading back to Melbourne today, and we'll see you for our final masterclass on Friday at 10:30, how antimicrobial resistance in animals impacts public health. We'll see you there. Thanks, Danica.
Thanks, Julia.